Hello. You've known me for quite some time now. I probably have talked about this before, and that's because a lot of people have talked about it before. But this is a very new, as you can see, 19 hours ago video. And again, it romanticizes the idea of what is happening with light. Unfortunately, the concept of using waves to express how light works only works when you're ignoring the individual particles. When they have the individual particles, they noticed it just shown on a single spot, making a little dot on the wall, and that's what you would detect. Sending multiple particles of light would give you the same interference pattern. Now, you have to understand, when you're talking about it like this,
to a detector on the far side. When this was done, the detector registered the arrival of the photon at just a single point. So, light was behaving like a particle again. But then, why had it interfered with itself in the previous version of the experiment? Scientists had an idea. They sent through multiple photons, one at a time, and plotted the result on the detector. And this is where the result became really strange. Once again, the detector started seeing the photons arriving at single points, one at a time. But bafflingly, the arriving photons started.
here's the thing. The journey of your learning about how light works isn't important to express the knowledge of what we know of light to do. Stop it. Some idiot said that light works as a wave at some point. Well, I shouldn't say an idiot. Some person who had a limited understanding of the basis of what was going on determined that light must be a wave. So they put that into the vernacular, they made that into the doctrine, they made that into what we understand. However, when we did this experiment, we showed individual particles affected by a wave. This happens really commonly in a game of poo sticks. What? You're talking about a children's game? Yes. Well, where's my comment? Unfortunately, double slit experiment only proves that there is a wave traveling through the double slit. It doesn't prove that light itself is a wave. So let me just explain it. You can read it whenever you want. The double slit, and the way that works, you've got the particle going through it, right? There's always, as the particle is being sent through, the same interference pattern making mechanism there. Now, why would that be? Well, that's because when you're sending a photon, you probably should realize the electromagnetic field is always there. Like a liquid, it's flowing through the double slit and making the interference pattern. The particles are affected by this interference pattern. This makes it very clear that light is a particle affected by a wave. We already know that electrons are affected by electromagnetic fields. Why would light be any different? And this totally, the reason why you understand individual particles being affected by a wave is so important. You can no longer think of light as just an excitation of the electromagnetic field. It is not that. It's an object in space. It is an actual dot. And the reason for that is because electromagnetic fields and waves and things like that, tiny little packets of these things, can't actually be just waves, right? They have to also be they have to dynamically be particles. What you're noticing when you notice the frequency be different is you're noticing that is the major thing that changes everything. When you put the light through a crystal, you end up spreading it out and having all the different types of expressions of light be shown through a crystal, right? Or whatever atmosphere you want. You end up with rainbows and stuff like that. I'll make a pizza pocket happen. So you gotta ask yourself, why in a year of enlightenment of our Lord, friggin' 2023, we talk about, or he, or anyone, any scientist, communicator, is going to talk about the journey of scientific development of theory instead of the knowledge of current scientific fact. I could talk about scientific theory that's from the Neolithic age. It's not applicable here. And if I want to talk about the history of scientific theory, I could go throughout the entire history of the universe and tell you everyone's opinion of what anything ever was. Does it contribute? No. Light is a particle. This is as much, to me, a fact as it's so interesting that we emit infrared radiation or heat. And heat is determined to be just another way of saying atomic and, like, more likely also some atomic speed. So when a particle has energy, it makes heat, which is weird. So the fascinating thing that I find about all of this is that when light is working, why would it want to interact with sugar molecules? What's so special about sugar molecules? Well, they have a specific design to them. They have a surface area that is more likely going to bump the light into certain directions. This is also something that proves that it has to be an object capable of interacting with things. Although that's a very bold statement to say, you might say. When I look at these videos, I end up getting so bothered. And I make so many videos talking about how no one whoever talks about the double slit experiment ever says it in like a correct way. They always say it in a way that is trying to have you discover what's happening. There's no reason to do that. The facts are empirical. There is no discovery that needs to take place. You just need to, when you talk about an engine, you simply state the facts. When you talk about light, you talk about it as if it's something mystery, and it's not. We got the particles, they're affected by electromagnetic spectrum. The electromagnetic field is its own thing, right? But then, yeah, the only thing I end up stuck on is the frequency of light and how that changes. Like, why would light even change into redshift? You know? Because if light starts off as luminous and amazing on one side, then why would it spread out at all? The answer to that is kind of simple. As light travels through space, in extreme distances, by the way, it redshifts. The reason for that is because over time, the individual particles are not actually all traveling in the same direction. They're spreading out. An individual particle and an individual beam of light is impossible to maintain over extreme distances. Anyone looking at a flashlight will tell you that when it's closer to the wall, it makes a smaller diameter. And when you pull it away from the wall, it spreads out and it gets dimmer. This happens, however, also with the light from stars. You might have a bunch of light that all came from similar locations, like a star, which is massive, and that star is going to show you a laser that is like able to have light constantly be in that same direction. So really, what normally shifts the tone of light? Well, it's an atmosphere. If you then think of space as a possible atmosphere, that could be the reason why it redshifts. And the other reason could be simply because, not because space is expanding, because that's a little bit on the extreme side. Thinking of space as an expanding object, and that's why you're having light affected. It's a little bit of a stretch. But people believe that anyway. No, what's actually more likely to happen is that individual particles are no longer traveling on the same basic direction. Their tiny narrow beams are all spreading out. So literally billions of light years, and then suddenly it starts turning into redshifted light. They're traveling at an insane speed, and it takes billions of years for the light from billions of light years away to get to us. That's why we call it that. What's the actual distance? I don't know. No one really talks about it much. I could research it. I don't care to. The point is, if you were to say, like, it's we know the knowing the speed of light and knowing the distance we're talking about, you can do the calculations yourself. It's near 300 million meters per second. Translate that into years, and you end up with a distance. Do proper math and have the actual values, and you'll get a proper distance. Because you'll be way off if you just use 300 million. The point is, if it takes 300 million meters in a second, then in an hour it'll take 60 times that. Nope, that's not right. 360 times that? Yeah, in an hour it'll take 360 times that. And then in a year, it'll take whatever that metric is. So,
creating a pattern. It was the interference pattern, the proof that light behaved like a wave. But strangely enough, this was only occurring when a single photon was going through at a time. Somehow, the single photon, which was leaving the detector like a particle and was arriving at its destination as a particle, was apparently in some way traveling through both slits at once, enough to then interfere with.
okay, first of all, your communication of it's traveling through both slits at once is a question, not a statement. You're not supposed to be making questions in these videos. The particle goes through one slit at a time. It can only go through one of the slits at a time. The electromagnetic field, however, can be interfered by both and go through both slits at the same time. The electromagnetic field is what's making the interference pattern. This is kind of obvious to literally anyone who knows about how magnets work. Same difference. The electromagnetic field is everywhere. It's enough to pick up a car. It's enough to span space. And you're wondering, and you know that electrons work as tiny little magnets. So I don't know what a photon is, but it's even tinier than electrons by an order of magnitude, and it also is a tiny little magnet. A particle that travels through space is interfered by the interference pattern and only is able to travel through. This is also what we call standing waves. The interference pattern is created by when one bubble of the wave is heading in one direction and the other bubble is heading in the other direction, your course is going to be in the middle. That's what's happening. And so by making the two slits experiment, you're literally forcing the electromagnetic field into those two bubble patterns. That's the three-dimensional representation of what's happening. Now, when you look at it from a water perspective, you understand how this works. You get it. It makes total sense to you. And yet, when you go to the actual thing that you're trying to talk about, you stop thinking in those terms. You start thinking about it in other ways. That's not okay. I don't know why after just doing an advertisement, it decides it's going to do another advertisement. I don't care. Yes. This picture, this image that we're dealing with here. So what happens, these dots represents the slits. And what you're really noticing here is that two sources of whatever it is in a two-dimensional plane, although you should see it as three-dimensional plane, but that's a little complicated to visualize, so they do 2D. It's fine. It still works. These interference patterns happen because, as you can imagine, the bubbles can only press up against each other, and everything else makes these empty spaces where the bubbles are able to exist and not just press up against each other is those lines that are this way, and where they collide with each other is the lines that go outward. The interference pattern we see on the wall. Meaning there's an electromagnetic spectrum doing this thing on a constant basis, affecting the light, which is a particle, only able to go into one of these places because the waves of the electromagnetic field are bubbling, forcing the push on both sides, forcing the direction of it to be only in those distinct directions. Where it comes out of the particle gun, the light emitting gun, determines where it's going to hit on the very minute differences of where these interference patterns begin, the very tiny bits. These two dots are where this dot here and this dot here are the intersection points, those double slits themselves. The unfortunate representation here is that it's two dots making this. This is a better representation, and so you understand the fact that there is a fluid there, is going through both of them. What you're not showing is the back end of it, where it starts as a singular wave, and then as it goes through, it interferes with itself. It makes this pattern, because it starts off as a singular, but it then goes through. And of course, the detector will only show later on that the photon is actually only going through one of them at a time. But we still see the interference pattern. So why is it when we have a detector that anything would be happening to the particles to make individual dots instead of the interference pattern? Anyone want to guess? That's right. These detectors, okay, they're not on screen yet. Give me a second. These detectors are emitting electromagnetic field, canceling out the flow of electromagnetic field through the slits themselves. Meaning there is no wave of energy going through the slits. There can't be, because we're interfering with it. We are literally putting another wave and saying push, and everything is just halted at the double slits. So what we end up with are dots on the wall.
But at the same time, it stopped creating an interference pattern on the further.
Yeah, it stopped creating the interference pattern. I know you can't hear the video at all. What you should simulate next, and what you don't, is that these little sensors are making their own energy or whatever, a laser beam, or I don't exactly know, and the problem is this video doesn't tell it. Other videos do. I'm not going to find them. I'm in the moment kind of lazy. But the point is, he ends up talking about, oh, it matters. The light cares about whether or not it's looked at. No. Light doesn't give a crap whether it's looked at. It's like, I was shot out of a gun. Oh, look, there's a thing that I can only fit through. Ah! Thumbnail hole. Thankfully, they aimed me correctly, so I'm going through it. But there's a thing where the energy that I'm traveling along with is going to push me in one direction or whatever else. I don't know where I'm going to end up on the other side of the wall. Let's find out. If you slow it down really far and you look at the very minute details, you might actually be able to tell where the light's going to go. Because that's not hard to calculate. Go frame by frame and you actually know where the light was able to have an interference in some way. You know that the double slit experiment, the walls of that itself are made of stuff. The stuff has electrons all around it. The electrons themselves have the ability to bounce the light. So you can experience some kind of... Oh, and the silliness of this representation as an animation is that you're seeing dots when there are slits in the wall. You would see slits. Individual slits. You wouldn't see little round dots. Just putting that out there as a animator, you failed. So
Detector. And from this, scientists began to realize something.
That's not what you would see.
Light cared about being observed.
It doesn't.
To be clear, it didn't matter whether it was observed by a human eye or a machine. The moment light was interacted with in some way by any particle, which is the only way we can detect light, there's no other way to observe it, it started behaving differently.
You know, you talked about light and everything else. What happens when you try blowing a bunch of water towards the other water that's going through the double slit on the macro scale? Do that experiment. You're going to find the interference pattern disappears. Because now it's all flowing in one direction. A more simple system.
Than if it hadn't been detected at all. It was if light was snapping into focus anytime the universe asked it the question of where exactly it was. When, without the scrutiny, it appeared to relax into something a little more nebulous. Bizarrely enough, to me, this seems to imply that light actually is more like a wave of probability rather than any discrete particle or wave. Anytime it was asked,
light is a particle affected by a wave. There are two different things. It's like a little dot with an aura. A little halo around it. Or it's like a thing making a lot of sound. We can consider the electromagnetic field being affected by light as the sound on the electromagnetic scale.
Where it was, it confidently provided a definitive answer. It was at this point on the detector. It was not at any other point.
That's right.
But
It wasn't going through both slits at once. It was actually only going through one. So you sum it all together and you have a proper understanding. Light's a particle, it's affected by waves. The electromagnetic field is those waves. It only lands on one of the spots, depending on what's affecting it as it's going through that path.
Checking up on it, light seems to be traveling in all directions at once, in accordance with certain probabilities.
No.
If you ran the experiment multiple times, you could quantify those probabilities, discovering that it was more likely to be on the bands of the interference pattern and less likely to be in the gaps. But anytime a single photon of light was asked,
like I said, when the two bubbles of the electromagnetic field are going through the slit, and then when the single bubble of electromagnetic field goes through the slit, it separates as it goes through and turns into two bubbles. Those two bubbles make the pattern that we see. So it is literally being pushed in both directions. It can't go into those dark spots.
Gave an answer that was 100% concrete. This is highlighted through something known as the three polarizer paradox. Consider for a moment a pair of polarizing sunglasses.
A separate experiment.
Obviously, these reduce the amount of light that can pass through them, usually by about 50%, depending on the type of lens and the wavelength of light. They work by being formed of thin chains of molecules that run lengthways across the lens. Any light that oscillates in the same orientation as this lens gets absorbed. Any that is perpendicular to the chains can pass through without trouble. The interesting case occurs when a single photon is passed through an orientation that's diagonal to the lens. In this case, you don't get half a photon going through. Apparently, you can't just absorb part of the oscillation that is parallel to the lines and let through the other part that is perpendicular. Instead, the photon snaps into either the one orientation or the other. It either is completely absorbed or passes through entirely, but now with a new perpendicular polarization to match what it would have to have had to have been able to pass through easily. How do we know that the photon wasn't this orientation all along? Because of what happens when you start adding more lenses.
The interesting thing about adding more lenses is that you're also interfering with the light with every step, and the interval of light is on the order of magnitude of the tiniest little grains of sand, and then
are perpendicular to each other. Let's say
shrink that down another billionth of a size, and you get light.
That gets through the first lens has
so the distance between these two lenses is actually very vast when compared to a particle of light itself.
We see only black.
It has the ability to change its orientation.
At a 45-degree angle between the other two, and bizarrely, light starts making it through all three lenses again.
What's actually happening is called
more blockages.
These lenses are actually guiding systems. Kind of affecting light as either a vertical or a horizontal slit. Electromagnetically, the light can just simply be like any magnet going to another magnetic field. They tend to line up when they get to each other. So what happens when you get to one of these, literally called a polarizing field, is that you end up being lined up with whatever that field happens to be. That further proves that light is a magnet. Just like the electron, only much tinier. It's affected by each polarizing field individually, because the distance between each field is actually
But this result actually rules out the possibility
far enough
that the light
that
has
they
a
can
fixed
actually keep
orientation.
on
It
twisting
must be
as they go.
snapping into focus at each new lens, rolling a quantum dice each time to see if it was the right orientation all along or not. If it makes it through the first lens, a 50%
If you think
chance,
of light as a
it only
little
did
tiny
so
magnet,
because it was
this makes
oriented
complete
perfectly
sense,
perpendicular
instead of the
to
gobbledygook
lens's
he's saying.
polarization. Which means once it
It's
reaches
disturbing.
the second, it's coming at it from a polarization that's diagonal. So once again, there's a 50-50 chance that it makes it through. It rolls a quantum dice again, and once again has a 50-50 chance of
No. Again. Why would you think of it as a chance? Well, the reason why we think of it as a chance of it happening is because some of the light is moving in the straight up and down perpendicular to the filter. Some of it is going in the opposite direction, wobbling in a different way. You end up wondering why that is. But anyhow, knowing that magnets like to snap to the magnetic north and south pole, then you can expect that to happen with light also. It is literally a magnetic field in the polarizing lenses. You should understand this.
eating.
But you don't,
If it gets through
and
this
so
hurdle
you
too,
tell
then it
people
again
false
snaps to the new
information, and
orientation,
I don't
as
like
if
it.
it were that new orientation all along, which it obviously wasn't. Which means that now it's polarized diagonally relative to the third lens, meaning that it now has a final 50% chance of getting through. Of course, some photons do not make it through all three of these probabilistic gauntlets. Only about 12.5% of them make it, but that's more than 0%, which is what was happening previously when you only had two lenses. Light likes to behave in discrete quantities. It is quantum. It seemingly
Some of the
snaps to a
light is not
discrete
able
value when
to
observed,
make that
and
transition to
honestly,
line up
we
with
don't really know why.
the
If you think about a
polarized
wave,
lens,
there is no
so
reason
it's
why you
stopped
couldn't
by
simply
that.
have half a wave.
The rest of the light
You could
is
half
able
it
to
again
twist
and
and
again
turn
an infinite number
into
of times
the
and still
direction of
have
the
an
lens
answer that
because
makes
the magnetic
mathematical
fields
sense.
of it
And yet, it
are
seems that
doing
down
that
on
to
a
it.
low
It's
enough quantum
forced to
scale,
do it.
you can't half light past a certain
So
point.
it's really
You can't
impossible
have
to
half a
think of it in
photon,
any other way.
or even
It is a
1.5
particle going
photons.
through space.
And if you
It's
try to
a
do so,
tiny
the
bar
photon
magnet just
instead
like the
snaps to
electron,
one or the other nearest integer. based on
and it's
probabilities,
affected by
but
electromagnetic
only
fields.
when it's asked.
Why do you need to complicate it
Otherwise, it's
by
quite
saying
content to
probability
exist
waves and blah blah
probabilistically,
blah and how it
interfering
is
with itself like a
actually
wave as it
an
travels
energy
along,
thing?
before
Instead,
jumping
it's
to an answer when
no,
later
it's a
asked
particle.
exactly where it
It's
is.
affected by waves.
What is going on here? This is still being theorized.
Okay, this is wasn't this
the closest comparison we have?
That pattern looks like something that 3 red, 1 brown, or 3 blue, 1 brown. Sorry, I got confused with Nile red and Nile blue. Different scientists. Talking about the pattern that it was a spiral pattern made by prime numbers. It was interesting.
To it is something known as harmonics, where on a bounded string, only a certain number of waves can exist. On a guitar string, you can have 1 wave, or 2, or more, but never a number that isn't a whole number. It seems that light works in the same way. Perhaps something pinches the beginnings and the end of the path light travels down, although what this might be and what
You realize that if light has distinct frequencies, I can guarantee you it doesn't. There's a reason why there's a rainbow. But there's a reason why light might have certain amounts of waviness to it when it goes up and down like that. And that's because the oscillations are only capable of happening in certain distinct sizes. It's similar to how electrons like to orbit atoms on distinct orbiting they call it energy levels. So when the electron skips from one to the other, it emits a photon, which is interesting. So the electron orbiting an atom, having its distinct orbit and energy levels, is probably because possibly another thing to do with interference patterns. Now that I think about it.
mechanisms drive it
Or
are
standing
unknown
waves, I should
as of
say.
now. Fundamentally, though, perhaps the craziest thing about all of this is that this isn't just about light. Although we focused on light behaving like a wave and behaving probabilistically, all particles of matter do the same. Light is just another form of energy, and energy and matter are linked. Particles of matter, atoms, and even complex molecules have been shown to have wavelengths. Electrons are just as quantifiable and just as driven by probabilities as photons are.
Yeah, so it's interesting how electrons and photons both work with some mysterious force that we also fully know as the electromagnetic force that is around them. It is everywhere. It is the ocean that the electrons are flowing through. So you gotta know photons and electrons are both tiny little bar magnets.
Apparently all driven by probability, if you scale things down small
There's
enough.
no probability.
So what is everything truly made of? What makes up energy and matter that causes it to behave in the way it does? What is going on?
Interestingly enough, a photon and an electron, when you really look at it from on the very tiniest scale, if you were to actually look at it, it probably is still an object with a distinct amount of components. It's an engine. It's not just it's not just like an actual dot, you know. It's made of a bunch of stuff. These tiny little bits are also the same kind of stuff that you find when you have virtual particles. Virtual particles are the tiny little stuff that are traveling likely in different directions. And then when the virtual particle comes into existence is where these tiny little fragments bump into each other, creating a virtual particle. But then they go on their way again, and the virtual particle just disintegrates. That's why it's virtual. It doesn't actually exist as a particle in that spot. It exists as two parts that make a little boop the moment they show up at the same spot.
The hood of reality. Why is the universe behaving different when looked at compared to when not? And what does it imply to think that even
Asking these things as a question means you don't actually know, or you're trying to make it seem like you don't know, or we don't know, but we know. We know how magnets work. We know how electromagnetic fields works. We know how all tiny things are polarized and they work with this. So it's the same fields and it's the same stuff, so we can assume that the particle is just a tiny little bar magnet. It's so tiny that compared to a photon, an electron is like a planet. And the photon is like a person. That's the scale.
are on some level probabilistic. What this all means is anyone's guess. The person who figures it out will be the Einstein of our time. But for now, all we can say is that when it comes to reality, it seems the universe
I'm the Einstein of your time.
You and the world
I made this video probably 10 years
ago.
ago.
Certain than you might have thought.
This topic has been talked about more than just in the recent... Shut up. More in the recent 1 day ago. But it's been talked about for decades. And it's always the same idea. The same BS. The same romanticism. The same stuff that nobody wants as a real scientist. We want hard facts. And you're not presenting that. But this isn't just the stuff that he believes, it's the stuff all sorts of people believe, including NASA. Fuck you, NASA.
So completes our
Please get your act together.
Highlighting the strangeness of light. Take a breather for a moment. Give your
No, it's not just him being dumb. It's everyone in the scientific community being this dumb. That's the problem. That's why I'm making this video. Shut up. Learn correct science about light.
Love messing with us. As I just showed you, scientists debated about whether it was a particle or a wave, because it keeps exhibiting elements of both, seemingly unable to settle. Bizarrely,
it's ironic that you can't consider the fact that it is a particle affected by a wave, and that both can be like, you know, a balloon and a streamer, or the electromagnetic field around a balloon that makes it stick to your hair, you know? The balloon without the electromagnetic field has no effect with your hair, but it likes to just latch on there when it's inflated and it's... Have you ever done that? You put the electromagnetic field onto the balloon by making static energy, and then suddenly the balloon is affecting like a magnet. Yeah. Now think about a tiny little particle of light being that balloon. It has an electromagnetic field around it. It's not just a standalone balloon. It's an energized balloon.
It behaves one way when you're looking at it, but a different way when you're not. But
I hate
at
it
least
when you
its
say that.
speed is consistent.
Shut
Light
up.
travels at the speed of light. No matter your
I
frame of
insult you,
reference,
sir.
that
You're
one
being
thing remains the
stupid.
same.
Shut up.
I have some bad news for you. It turns out the constancy of light speed might not be right either, and the next few
Okay, no one who is a real scientist has ever said that light is consistently at the same speed. No one. A real scientist will never say light travels at the same speed, or presents it as if we ever thought light worked at only one speed. Going through a vacuum, it has a specific speed. That's because that's the only speed it can work at. It has nothing else to interact with in the vacuum. Once you go into a liquid or an atmosphere or whatever else, light has different things affecting it. It changes, turns from this lovely like see-through whatever to turning everything blue and shades of lovely sunsets and whatever you want to think of. And then as it goes into water, everything turns darker and darker and stuff and turns more blue. And there's reasons for that. But you'd understand if you were a real scientist.
Light might go slower than physics would predict in certain circumstances. And no,
Oh yeah,
I'm not just talking about light
you can
slowing
slow
down
down
in
light
dense
to like
mediums like
nearly
glass,
half its
although
normal
that's what I
speed,
originally
or
intended this video to be
actually,
about.
I think
We
the
have an
slowest they
explanation
ever
for that.
got was
I'm saying that in some circumstances, light seems
they
to
put it
travel
through
a
a
path through
certain
time
type of
and
solid,
space that has it either going slower
and it was able to
or
go as
faster
slow
than the speed
as
of light, even if dense
like a
mediums
car.
aren't present. But the really weird thing is that it ends up at
Light
the same
going the speed of a
destination in
car
space and time
is really
anyway.
slow compared to the speed that light travels at.
Let me show you what I mean. Light travels at 299,792,400.
Exactly. I said 300 million, I wasn't wrong. Now, consider it going instead only at 40 meters per second. Or kilometers an hour, I guess. If you go kilometers an hour, what is that in meters per second? Good question. They didn't tell us. I didn't do the math also. But if you simply take the 40 and you multiply it by 360, you get your answer. It's about 12,000 meters per second. Instead of 300 million. The point is they got light to go really slow compared to normal.
58 meters per second. According to relativity, this is the only speed light can travel at, and interestingly, seems to stick to that number regardless of your frame of reference. Two people could be traveling.
The reason why light isn't affected by your frame of reference is because you're not affecting how light interacts with stuff. The moment you start putting it through a substance, you're able to really affect it a lot. And we know this. It's not a question.
Through space, one at 1% the speed of light and the other at 50% the speed of light. But if they both look at the same beam of propagating photons, they will see them traveling at the same speed. Time and distance would seemingly rather warp than allow you to see anything other than light traveling at light speed.
The point is that it doesn't matter how fast you go, unless you're a substance or whatever else, you're not going to change how fast it goes. Funny how you say it in completely arbitrarily stupid ways.
Of course, when scientists say this, they are only talking about light traveling in a vacuum.
Yep. Get the fuck away from me.
Known for a long time that as soon as you get matter involved, light gets bogged down and travels slower. Light traveling in air only goes at 299,705,000 meters per second, a full 87,458 meters per second slower than light in a vacuum.
You know what would be better?
In water goes around.
You know what would be really good? You actually put the number above the other number and be like, this is how much it is in a vacuum, this is how much it is in the substance. And then also show the percentage of speed of light that it travels in the substance.
225 million meters per second. Light going through glass.
This is obscuring the facts.
Around 200 million.
Unless you can have,
for this are intriguing,
unless you
but
remember
fairly well
the numbers.
understood, and certainly not physics breaking. When light travels through matter,
So stuff of a certain density
fields
has a certain effect on how light is able to push through it. That's because
on water. But
light, like anything else,
up and down, also
literally,
generate an electric field.
I mean, it stops once it goes and hits a wall. So the more dense the wall, the less light's going to go through.
Overlaps the waves of the original light, albeit one that waves at a slightly different pace to the original light. Exactly what speed?
For example, this is a wall.
Material. When two waves meet, they
but
interfere with each
you can
other.
see through it.
They take an
because
average,
the light's able to get through all of
interfering
this.
constructively to build each other up, and
But
sometimes
this is a wall,
against each other.
and you can't see through it.
So when you take the grand total of all the ups
But
and
you
downs
can
of each wave,
see through it
you actually end up
if
with a new wave,
it's
one that
simply
travels at a different speed to the other two,
the
and
one
that goes slower
layer
than the speed
of the
light.
envelope.
Eventually, this propagating wave can reach the edge
One
of
layer
the
of envelope,
material,
you can
and
see right through it.
without those electrons interfering anymore, you're left with
Better
just the
example is if
original
I
light
show you
again,
like this.
which is then free to travel
See how
along
it's
its original path
lighter
again
when it's just
at
the
its
one
original speed, as if
amount
nothing had
of
ever
envelope?
happened. Scientists have had a lot of fun with this concept over
That's
the
because
years.
light's actually able to go
Researcher
through it.
Lene
It's not a
Howell
solid
at
wall.
Harvard in 1999 was able
Very
to slow
simple.
down light to an astonishing 61 kilometers per hour by sending it through a cloud of sodium atoms that had been cooled to 1/1000th of a degree above absolute zero. 2 years later,
So
Howell
okay,
managed to slow down light
they
speed
use the
to
same
zero
stock footage
before
of
warming up the cloud and sending it.
that exact same experiment. Everyone talks about it. They use the same visual. Weird. But whatever. Means that they're not actually making the animations themselves. Only finding what it feels appropriate to them. Anyway, the point is, the material slowed down to the speed in which it exhibits this temperature of whatever tiny temperature he said. It's really still, and it is really dense. It has a very solid structure. It doesn't bounce around like the fast stuff of the warm temperature stuff. It is really solid. It is really unmoving. And it is really dense. So it stays where it is, and is also thick. So light can only move at certain speeds
You
through
might
that
find
stuff.
that result surprising. However, Strange things have happened in the opposite direction too. In 2000, researchers at the NEC Research
But what
Institute
you're not understanding, perhaps, is that when light is going through something that's really cold, the electromagnetic field in that is like, you gotta understand that there's some powerful electromagnetic fields going on in there. As you see in any superconductor, when you use like liquid nitrogen on the magnet thing, or whatever it is, the superconductor will then levitate on a magnet. It'll just, as long as it's cold enough. So the electric field could be what is interfering with the light, not the substance, but the energy in that substance. It's not just the size and the coldness of it and whatever else. The coldness also affects the electric potential, and like any magnet going through a tube of copper will slow down as it goes through it, light going through an electromagnetic field substance is super slowed down. Now, what happens if the electromagnetic field is turned into a magnet field or a accelerating? Suddenly light is going faster than the speed of light. You can totally do this.
Princeton, New Jersey, sent a pulse of light through a cloud of cesium atoms. Alarmingly, when they tried to see how quickly the pulse exited the cloud, it seemed that it exited before it had entered. While this might appear to mess with...
Okay, when you're talking about an order of magnitude such as light, it is possible that, like I just said, you might end up with something that is so energetic that it helps the light go through faster. That the moment you touch it on this side, it emits something on the other side. The beam itself goes through later. That's because the beam is like particles and electromagnetic fields. What they're noticing in this literal description of it is that the light, the visible part of it, is going through, and the electromagnetic field is being shot out at an incredible speed. Yeah.
Causality. How can you leave a building before you go inside it, after all? Fortunately, there was a simple explanation that saved us from
If you think
creating
about light
too
as
many
the two different
paradoxes.
components, the
Although
particles
the light
and the
pulse
electromagnetic
traveled
field,
faster than light, the light
you would
itself
properly
did
be
not.
communicating this.
This was more
It's
an
literally
optical
communicated
illusion
in
than
the
a
animation
refutation of
itself.
Einstein's
Not
relativity.
made by him, but
Let's take a closer look at a photon of light. As Einstein showed
people like
us,
to say
each
whatever they like
photon
to say.
represents
It's
a tiny
really
packet
annoying.
of waves moving up and down. The speed the waves inside the packet propagate is known as its phase velocity, while the speed at which the packet as a whole is traveling is known as the group velocity.
Yeah, and if you were able
You can also have
to spread that wavelength out so that the up and down travels a very long distance instead of really short frequencies, which is what was happening with the other stuff. It takes like no time at all for that wave to go through. The particle itself still has to take its time.
a wavefront velocity, which is how fast the first photon in a wave of photons can travel. This is a little heavy in its terminology, so let's explain it with an example.
Nope.
Think of a crowd of people doing a Mexican wave.
Wow, you
The
did the
wave that the
exact
people
same.
are doing is the
You
phase
stole this
velocity.
video.
You can see the wave
The other person
traveling
also
along
talked
through
in
the
the
crowd.
exact same
It might look like it's traveling
stuff.
quickly, but the
You're
crowd
not
itself
even.
isn't going anywhere. So our wave.
This is flat out plagiarism. You're using not only the exact same the exact same images. I seen this exact same stuff said by a different science communicator. Alright? It's like they're using the exact same, that the presentation was made by someone else, and they're just ripping it off, and they're using it in their own video. Likely not referencing who the hell made this presentation, because it wasn't you. We know it wasn't you. You took it from somewhere. Why? Because people are really lazy. They don't want to make stuff themselves, so they find stock footage. This is what's happening. But it's the exact same stock footage between this and a different person who also talked about light over a week ago. Maybe a month ago. I don't care.
True speed is 0. These people are the group velocity, or possibly the wavefront velocity. Let's imagine that we wanted to send our crowd marching. They could do so, and could keep doing a Mexican wave as they traveled. But although they're waving...
See, you realize you could do a better example if you actually had all of the people, except for one, be up. And then you could also show individuals all waving their hand. Difference of the all versus just the one. It seems like the one is traveling really slowly. The all is traveling almost instantaneously.
Might make the wave go really fast in the direction of their travel. It would vanish whenever it reached the front of the crowd. Information exchange couldn't go faster than the walking speed of the crowd itself, regardless of how fast the peaks in the wave seemed to be traveling. Einstein, in relativity, never claimed that phase velocity couldn't exceed light speed. He just claimed that information couldn't travel faster than light.
And that's because you don't know how to measure the peak and stuff velocities, the frequency of the wave. But you can actually, and therefore information can be transmitted and converted at a high rate. Much faster than... In fact, we use multiple frequencies in order to transmit as much information as we possibly can. Gigahertz and all that.
And if you're trying to deliver a message to someone by sending a crowd of Mexican wavers in their direction, it really doesn't matter how fast they're waving. Until the first person in the crowd arrives, no information can be delivered.
Did you literally rip this off?
This difference between the waves within light and the speed of light itself will become interesting in our next experiment.
Maybe
and this is where things start to get
a little editing here and there.
Oh, you thought it was weird already? Oh no, this is the really physics-defying part. Let's think back on the double-slit experiment.
Please don't.
There, researchers explored how light can sometimes behave like a wave and sometimes like a particle. However, in 2023, researchers from the Imperial College figured out a way to separate the slits of this experiment, not in space, but in time.
They did the exact same video, the exact same wording, the exact same wording in another video. That this is like, oh, I'm gonna say the exact same stuff as someone else, only with my voice. Like word for word, the script is just ripped off now.
Material called indium tin oxide that, under specific conditions, can be made to be reflective.
Because really, what they are doing, if they're doing anything, is they are taking a paper that talked about all of this stuff, and they're saying it in the way that makes sense to them, which is the exact same way the other person said. Or you just watch the video and then you're like, I'm gonna mimic that and do the exact same presentation. Why do you think this is helpful?
oxide is the stuff they use in most mobile phone screens.
You're
They
redundant.
fired a laser at it, and then rapidly changed the material from
You might be
transparent to
more,
reflective and then back again.
like
This
people might
left
be able to
only a
listen to
slim
you
window,
more than
a
other
few
people.
femtoseconds,
That's
where
sad.
the laser was reflected. They called this a time slit. They recorded what the laser looked like after it had been
Hold on.
reflected, and oxide that, under specific conditions, can be made to be reflective.
Specific. You used this exact same wording as the other video I saw already. Specific conditions. Wonder what that is. It's probably a polarizing lens.
Indium tin oxide
Electromagnetic
is the stuff they use in most
polarization
mobile
instead
phone
of
screens.
static polarization.
They fired a laser
Where
at it, and then
if you
rapidly
put
changed.
if you put in a little bit of energy, it'll polarize, right? Like a crystal deciding to correct its orientation because the energy is going through it. And what happens is you're also having the potential of any other position that crystal could be in. So we end up with weird stuff when we reflect that light off of the thing.
Material from transparent to reflective and then back again. This left only a slim window, a few femtoseconds, where the laser was reflected.
Yeah, you know how fast a femtosecond is?
They called this a time slit.
Uh-huh.
They recorded what the laser looked like after
The
it had
other
been
video
reflected,
talked about how
and
fast a
found that its
femtosecond is.
frequency had spread out a little bit in the process.
Femtosecond is like, the numbers is 1 to the 15th or a billion million. You can say it either way, I don't care. A million billion of a second. And we know that in the order of magnitude of light and how that works, when you think about an individual particle, when you think about the speed of light per meter, right? If you're going at like 300 million meters per second, then if you go 1,000 times smaller, you're going 300 billion. Femtosecond is basically that. It's at a frequency determined by the electromagnetic field. They basically had to have the tiniest amount of flick, and it's like, boom, energy changes it, makes it do a thing. And it has the potential of being in any of those positions because of the electromagnetic field. He doesn't talk about even the speed of a femtosecond. That's where you're lacking.
What happened when they
The
sent
other
two
video,
pulses through these time slits in rapid succession. The position
the
of
other
the
video
emitter
was at least smart enough to say how fast a femtosecond was. You're not. That makes you a worse science communicator than the last person. And I can't tell you who the hell made the original video. But you can find out. It's probably either Veritasium or Space-Time. I think it's Veritasium. It could be another person, but I'm almost certain it's Veritasium made this video.
Mirror and the receiver remain the same.
They presented it with more accurate and more...
lasers went through. Oddly enough, when two went through, an interference pattern happened.
Reincarnated into another world? Who would you like to marry? Well...
Oh, God. So again...
Companions or wait?
This was not an interference pattern in the same sense as with the regular 3D space double-slit experiment, though. This was an interference pattern that had affected the laser's frequency. Certain frequencies of light
Yeah, well, it's possible that the crystals being affected in those, metal's a crystal, right? When you look at it, it's just a tiny little particle stuff. It's in a crystal structure. Moving on. The point is, these tiny little bits that you are polarizing with the tiniest amount of strong electric shock, very, very fast acting, tiny amount of time, powerful electric shock, makes the stuff in that material, in this, whatever it is, whatever they made this out of, it changes its orientation to be reflective towards the collector, sensor, whatever you want to call it. So what's happening on that atomic scale, energy goes through it and suddenly it wants to reflect. Literally at any, like I said, at any point in time, you can have the crystal be in this position or anywhere between reflecting and normal, letting it through. So, blah, 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 blah.
When 2 went through, an interference pattern happened. This was not an interference pattern in the same sense as with the regular 3D space double-slit experiment, though. This was an interference pattern that had affected the laser's frequency. Certain frequencies of light within the laser faded out, exactly in line with the way intensity faded out in the regular version of the double-slit experiment.
So, and when I saw the original, this is why I made this video, because someone else also talked about this. I react to the exact video because of the way you are interpreting the information. It's annoying me. First of all, you don't see the interference pattern be the same just because what you're actually experiencing is the frequency is changing very tiny amounts as the crystal is turning into the reflection orientation and the let it through orientation. Or don't you know particle physics? I've said it like 4 times now.
To visualize why this might be happening, let's draw out this experiment in regards to time. The time slit experiment can be drawn in a similar way to the double slit experiment, except
you're also going to have
change in the experiment over time. To do that,
you said the exact same, the same Oh my god. You're just taking the same exact presentation. Whoever the hell made the original presentation, you're still getting it wrong. But then this guy's just reverberating your presentation and just his own words. Or his own, like he's just a parrot. You know? And I feel sorry for you because you're not an actual scientist. Analyzing and talking about proper things with proper, like, analysis. Your own interpretation of what's happening. You're just reading out the thing from the script. I hate that.
To the color we perceive light to be. Lower frequency light is redder in color. Increasing the frequency shifts light's color towards blue.
Yeah, that means that some part of the light was reflected in a way that would make it
less sense is what's going on.
In the same way that you understand when light goes through the prism,
remember,
and it splits into the different parts.
We started with represent the 299,792,000.
The different angles that light approached the prism is what makes those.
So what can we say about the photons
bits of the rainbow? So you can understand.
For some parts of their journey, they are traveling slower than the speed of light.
I don't care. Shut up. Shut up. You're not talking about physics anymore. You're not. No.
universe apparently can go. And yet, it seems to me, in its efforts to locate...
I don't want to hear it, because it's gross. If you just think about how prisms affect light, and how they turn it into the different colors, you can understand that the shape of the prism and the way that the light was passing through it means that the direction of the light at one point was turning into this color, and the direction of the light as it was turning, as that crystal was turning, turned it into a different color. This is about how the light was affected by the tiny little prisms that the thing is made of. Electrically induced twisting of those prisms into the light will go through solidly, or it will be reflected. So that you're just proving that the prisms were at a different orientation, and that's what makes the different frequencies. Who cares?
Exactly.
But you say it with mystery and mysticism and bullshit and then
putting out feelers that
blah 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 blah.
And seemingly
Romanticism.
other paths through time itself might present a more viable solution to at least different directions to vanishing and collapsing. Or perhaps some other phenomenon is that we can figure out. There's a spanner in that. But sadly for our aching minds, it's not the only experiment to do so.
Really? Your minds are aching because you don't know how prisms work?
Break time over. Can information travel backwards in time? It's the sort of thing that would be really useful if it were true. You could tell...
Are you... This... Okay, in the other video, they also talked about how you have two of the lights.
Your past self not to eat that burrito that didn't agree with you, or you could reveal to yourself the winning lottery numbers, but it just doesn't happen. The resulting paradoxes alone would make the whole thing laughable. In our universe, time always seems to flow in one direction, forward. The idea of traveling backwards in time, or even simply communicating with your past self, seems so outlandish, it can't possibly be true. So why is it that on the quantum level, information seems to be doing just this? Alex, stop, you might be saying. You've already shown us that the solid universe around us might be nothing more than probability waves, and that light has some weird element to it that causes it to interfere with other...
There is no probability. And the light is not traveling backwards in time.
Light in its past and its future. But this, surely it's impossible for information to travel backwards in time. I understand the sentiment. It goes against all intuition, and by all accounts, it doesn't seem possible. In previous videos, I mentioned that objects would require infinite energy to even go fast enough to reach the speed of light. So how could something go so fast as to reverse the usual direction of time and arrive at the destination just not instantly, but before they left? Not even light can do that, and it's the fastest thing we know of. Well,
What?
This rule about causality speed limit seems to mostly apply to the macro scale universe. And by macro scale, I mean everything significantly larger than an atom. But down on the quantum level, time might be obeying different rules, or at least the speed of causality seems to come with some significant caveats. And to demonstrate this idea, we need to look at a man called John Stuart Bell and quantum entangled particles. I should apologize in advance for what I'm about to do to your understanding of causality.
You're not gonna do shit to me.
But what are quantum entangled particles?
Where the fuck am I going?
Okay, but what are quantum entangled particles? In quantum physics, it's possible to hit two particles together in such a way as to link them together, so that by measuring the one particle, you learn things about the other. For instance, if you know that the particles...
Quantum entanglement. I'm just gonna blow your mind right now. If you haven't heard me say it before, you're gonna hear me say it in this video also. The quantum entanglement experiment was to send a photon of light to a specific crystal structure that divides it directly in half, and one half goes into the one detector 100 meters away, and the other one goes to the other detector another 100 meters away. And what they noticed is that when they looked at, once the photon actually got, the half photon actually got there, that it exhibited characteristics of it being like, what do you call it? Right facing or whatever. And the other one experienced left facing most of the time. I do repeat, most of the time. Because when it comes to light, moving at extreme speeds in entirely small sections, you need to be able to be accurate to, again, the femtosecond, which is 10 to the 15th power, bits per second, whatever. And on those magnitudes, on that amount of like moments of instantaneous movement in a single second, it's hard to keep everything straight. So the timestamps of what was happening, the distance could be affected by the tiniest little fragment of space, and it would change the experiment entirely. The point is, we only saw they were similar enough we can tell that one half of the light was one direction, and at the same time the other half of the light was the opposite direction. My brain interprets this experiment as a tennis ball being cut in half and sent in two directions, to be noticed later. There's no causality in that experiment, but they thought there was. They gave a Nobel Prize for it. I'm disgusted by you.
Had a total of 0 momentum, and you learn the momentum of one of the newly quantumly tangled particles, you know the momentum of the other particle will be the exact reverse, making sure...
Hold on, did you just say something actually completely, and I will say this bluntly, dumb?
Of one of the newly quantumly tangled particles, you know the momentum of the other particle. The man called John Stuart Bell, and quantum entangled particles. I should apologize in advance for what I'm about to do to your understanding of causality. Okay, but what are quantum entangled particles? In quantum physics, it's possible to hit two particles together in such a way as to link them together, so that by measuring the one particle, you learn things about the other. For instance, if you know that the particles originally had a total of 0 momentum, and you learn the momentum of one of the newly quantumly tangled particles, you know the momentum of the other particle will be...
It's called spin up and spin down. The momentum is not what we're looking at. The fact that you say momentum is like you're introducing a completely different idea, and that's not even what we're looking at. So, not only are you a bad science communicator in that you repeat stuff that people are saying, but you put your own spin on it just to look different, I guess. And you say something as simple as momentum. Spin up and spin down is not the same as momentum. And if I was only listening to you as a science communicator, I would be misinformed. Thankfully, I'm not. I listen to all sorts of people, and I also understand quantum physics myself. So when you say momentum, that's a blatant lie, or fabrication, misunderstanding, or just being dumb and not okay.
The exact reverse, making sure the total remains zero. Effectively, by measuring the one particle, you can learn things about the other. This works for other particle properties too, such as position, polarization, or spin. On the surface,
Yeah,
there's
spin, wow, the only thing we're actually looking at. We might be looking at polarization also, but momentum? Where the fuck did you even get that from?
nothing too weird about this. It's no different from me meeting up with a friend and discussing our plans for the evening. We agreed to go out, and we agree that I will pay for the evening and my friend won't. Then, no matter how far we go on our night out, or even if at some point separate, I know I will be paying and my friend will know that he won't. This is how Einstein thought it worked.
It's a lot easier if you actually think about the exact... The thing is, you literally had to shove in a different analogy to try to make yourself look smart. The thing is, it's like the right and left-handedness. The right and left-handed glove is really simple idea in that you understand a right hand doesn't have the full reflected thing as the same as what a left hand would look like. For example, the top is always on this side of my hand. That is the left hand. To the camera, you think of it as the right hand, but that's my left hand. This is my right hand. The point is, the side that the face of my hand is on is this side. My thumb is here on the top. My left hand has the opposite qualities, where the face is this way and the thumb is on top. But my fingers are facing the opposite direction. The right and left-handedness of the spin of particles and all of that is similar in the fact that they have a certain direction they prefer to spin in, and that happens to be correlating with a specific direction we talk about as right-handedness. It curves this way. And whichever way that you're looking at that particle, it will curve that way. So when you split the particle in two, one particle will be the exact opposite image of the other one, because the one is actually in the image going this way, and the other one's in the image going that way. But if you were to do a 180 on it, they look exactly the same. There's a reason for that.
Only it turned out that Einstein was wrong. Because as it happens,
I don't care to find out why you were
friend
saying
did
that.
not discuss in advance who would be paying. And the strangest of all, we still both agree with each other anyway, 100% of the time, no matter how far apart we are. This is the strange thing about quantum entanglement and quantum physics in general.
The truth about quantum
to
entanglement that some people try to say is that when you get there, you're going to choose whether or not I pay or you pay. And it doesn't matter what I want, and it doesn't matter where I am in the universe. If you say I'm going to pay, I end up paying. Instantaneously, that's what happens. Right? That's not what's happening, because the particles were separated by a system that distinctly split them in two. It distinctly made individual bits that were definitely going to be in the I'm paying or I'm not paying situation. This is what they call um, what did Einstein say it was? Unseen factors? Whatever.
Particles as having fixed properties.
Paraphrasing.
However, our penultimate
Scientists do
mind-bending
that all the
experiment
time.
shows that particles only have properties when you detect those properties.
That's
Yes,
not true.
it's like the double slit experiment again, only that was focusing on a photon's position. It seems that particles
It seems that the way that you're detecting them is also affecting how the particle reacts and does a thing. But the idea is that when you do something and notice it on this side, the other one snaps into position doing a specific thing that you will notice on the other side. The thing is, communications are said to still not be possible of happening this way. If it truly worked that you could do the transmission of whatever was happening to the particle to the other particle, if you have like 1,000 of them, you can have a small picture. And it doesn't matter if some of them are correct and some of them aren't. It'll be like a blurry picture with some mistakes, but most of them will be correct and you'll get most of the picture. And the more accurate and the more particles you have, the more accurate the picture. And therefore, you will know whatever the other person is trying to tell you with a lot more particles. However, I don't believe quantum entanglement works at all.
also kind of vague about
And
the
is a
whole properties thing,
continuing
instead
problem with
only relying
people.
on probabilities as defined by a quantum wave equation. This doesn't make sense intuitively. Looking at a thing shouldn't be what gives it properties, right? Well,
Yeah, no, it totally is, because when you have a magnetic field around another magnetic field, the magnet just snaps to orient towards it. So if you're looking with electromagnetic fields, you're snapping something to align with that. You gave it a property. You interfered. Like, duh.
how would you know? If a tree falls in the woods, does it make a sound? According to quantum physics, not necessarily. Let's talk about the
Okay, you're stupid. You're actually dumb. You can't say that. If a tree falls in the woods, would it make a sound? Okay. Considering that let's say that if you're near, the answer is of course yes, it freaking makes a sound. The thud of it landing onto the ground, whatever that ground was made of, would have the sound travel, and a seismometer would be able to see that a distance away. We can see earthquakes for crying out loud.
experiment. The maths for this is pretty complicated, but bear with me, it's worth the ride.
I don't like you're using these representations.
The experiment was first conceptualized by John Stuart Bell, who wanted to know if particles really did have secret properties that they carried around with them, known as hidden variables, or whether they really were making some of it up on the spot. He noticed an interesting mathematical fact about the spin of particles. Before we go any further, I should probably mention that quantum spin isn't the same as normal spin. Misleadingly, quantum spin actually defines whether a particle is influenced, pushed or pulled, by a magnetic field. The name isn't important, but it is important to note that these particles aren't actually spinning, and so can have different spin values in almost any given direction. Now, let's take two quantum entangled particles, and let's say that we've arranged it so that their spin adds up to a total of 0 between them. This means that if one particle would be pulled by a field, the other will be pushed by it an equal amount along that direction, with the understanding that this doesn't tell you anything about their spin in other directions. One of the features of quantum spin is that if we measure an entangled particle spin in any given direction, let's say up and down, it will have a 50% chance to be spinning up and an equal 50% chance to be spinning down. But remember, once you measure the other entangled particle, it will have a 100% chance to be spinning in the opposite direction to the first particle.
That's because when they were made, they were literally formatted in a way that the other thing is, depending on like where you are in space, what if it is that the particles that are entangled, they have a certain design, right? So it makes it so that when they're looked at like this, they will spin up because the one half of the particle does this one thing we can understand, and the other half of the particle, like I said with the tennis ball idea. Why can't you think about it in that way?
On this fact alone, there is no way to tell if the two particles already knew their spin or are somehow deciding it on the spot and conferring
You
it with
mean
each other
prefabricated or manipulated once they got there?
now that they've been asked. But Bell noticed a clever thing by asking a clever question. If you measured two quantum entangled particles from two randomly selected directions, what are the odds that their spin for different directions would match? Now, let's define that at any time a particle is spinning towards a detector, its spin is up, and any time it is spinning away from a detector, its spin is down. What are the odds that both particles would be spinning up or down when tested? And what are
That again proves what I just said, that the detector is doing its thing, it's aligning the particle depending on the physiological components of the particle. Its shape makes it spin up, and the shape of the other one is the exact opposite, making it spin down. It's like if you have a right-handed corkscrew and a left-handed corkscrew, right? If you try to use a right-handed corkscrew nut on a left-handed corkscrew bolt, you can't screw them together. They don't line up, right? They're the exact opposite of each other. They just don't do anything. But a right-handed and a right-handed, the screw and the bolt will twist together, right? This is the right and left-handedness of their spins, which means the physical manifestation of their being is that one is twisting this way, the other is twisting that way, right? Clockwise, counterclockwise. So it would seem like whatever you do when you quantum entangle a particle is forcing it to work with energy in a way that most likely makes it so it twists along axis with whatever thing, if that's what's happening.
odds that they would contrast? Let's formalize this with a little experiment. Here we have two entangled particles with three detectors.
You gotta understand, the interesting thing about the corkscrew idea is that how did they form the shape of opposing corkscrews. If you cut a screw in half, you end up with two screws. They are still of the same right and left-handedness. No, they are still both right-handed, right? Their turning, their twisting is in the same clockwise direction or counterclockwise direction, but it's both the same when you cut a screw in half. However, if you cut a screw in half and say you flip it 180, do they still look the same? Like physically, just get a slinky and do this experiment. You flip the slinky over, what does it look like compared to the other slinky? If I had a slinky, I'd be able to show you. But guaranteed, the slinky looks the same. In order for a slinky to become a different oriented slinky, it has to be designed to screw in the opposite direction. Right? That makes total sense. And therefore, you have to understand when you are creating the quantum entangled particles, what you're doing is making a particle on one half of the experiment that does screw in one direction, and the other particle screws in the other direction. That's what's happening.
Is reading their spin
Most likely.
in different directions. If particle A and B are both red with the top detector, then one of their spins will be up and the other will be down. They are entangled. This is what we looked at previously.
They're correlated,
However, if
not
particle
entangled.
A is red using the top detector, while particle B is red with one of the other two, these two directions of spin aren't opposites. So particle B has flexibility in which way it goes.
Hold on, what did you just
Red
fucking say?
with one of the other two, these two directions. If both red with the top, here we have two entangled particles with three detectors reading their spin in different directions. If particle A and B are both red with the top detector, then one of their spins will be up and the other will be down. They are entangled. This is what we looked at previously. However, if particle A is red using the top detector, while particle B is red with one of the other two, these two directions of spin aren't opposites. So particle B has flexibility in which way it goes. Quantum physics.
Isn't it more likely that you then oriented the particle towards the detector? Or did you just look at the... Are you able to look at the particle without affecting the particle? If it's polarized, if it's energy-based, whatever stuff, if the particle is affected by the energy, then you know that it's going to line up with that beam.
Claims the particles are making up their attributes on the spot. So once
Exactly.
you measure the spin of particle A using the top detector, it was a 50-50 whether the spin on the other particle using one of the other detectors would match or contrast. But this is not what classical physics predicted. Let me show you what...
You're kidding me, right? You know magnets is classical physics also, right? Whatever.
Classical physics.
You know particles are also moving at like thousands of
secret information
rotations per second?
their spin in any given
Or
direction.
millions or billions, I don't know.
For our three tested directions, each particle would have a value already. They aren't making it up on the spot.
They could.
Let's say, hypothetically,
because if they're affected by an energy field, they will change.
Up, down for particle A, and down, down, up for particle B, as B must be opposite to A for each of the directions 1, 2, and 3.
That's an assumption.
Let's pick out a random detector for A. We select detector 1. Detector 1 tells us that A is spinning
hypothesis.
up. Now let's select a random detector for particle B. We select 1 there too. this detector gives us a reading of down. 1, 1, up, down. We can
Okay.
actually map out all the possible outcomes of this process of random selection in the graph. There are 9 possible outcomes if you were to only measure from 2 detectors at a given time.
What do you
1,
actually notice?
1, 2, 1, 3, 2, 1, 2, 2, and so on. For each of these possible selections, we have fixed hidden variable results that we know already because we hypothetically defined them earlier. Let's fill them in now. Of course, if you detect particles using the same detector on both particles, you'll get a contrasting result because they're entangled. But we're not interested in these results. Classical physics and quantum physics both agree on this.
So, hold on. Again, you're only noticing the proper... Listen, when you really talk about quantum entanglement, when you really talk about whatever it is that is happening with a quantum entangled particle, the idea is that whatever happens on one side will affect and change what happens on the other side. The fact that you say that the one could be doing its own damn thing, irrelevant of whatever is happening to the other one, means there's no quantum entanglement at all. It's just a function that is made into and baked into their shape. And their shape is what is predetermined. Hidden variable. You can do this with like flows of water and a screw, and flows of water and a different size screw. And then the question is, what is actually making these quantum particles so that you end up with the flow affecting the screw? Like, what actually makes it so the screw would end up becoming that size screw? I don't know. I don't care. All I know is you're not saying
A
it
and
right.
B will see the same result, and what are the odds they'll differ?
What do you actually notice?
Remember, quantum physics expected it to be 50-50. Particles are making up their values on the spot, and so it's perfectly random which they'll choose, as they aren't confined by the opposites rule here. But in this table, classical physics says that contrasting results only happen a third of the time. The other times, they're either both up or both down. If we do this many times, assigning different directions each time, and ignore exceptions, for instance, where the spins of the particles are all up, 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 or down, 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 once you crunch the numbers, the important thing to take from all of this is that according to the maths, classical physics predicts a matching outcome 55% of the time, while quantum physics continues to simply predict 50%.
I don't care about predictions. I care about your actual measurements.
Table be damned. This percentage difference was the key. By quantumly entangling particles and running this test
And the other thing you have to notice is that there is no answers given in this video, just a bunch of questions. I'm giving you the answers. Light works by electromagnetic fields affecting the particle. That's what makes the interference pattern. It's the electromagnetic field. The particle rides that wave, that field. So it is a wave that is happening to the particle, right? The right-handedness and left-handedness of the particles in the entangled particles is that when you divide them, when you divide the particle into two, you're actually making one that has the screw in one direction and one that has the screw in the other direction. But I know why that's happening. The original particle was turning in one direction on its axis. clockwise, but facing you. When it was divided, this same direction was shared by both sides, going one way and the other one going the other way. It's still clockwise. But when you look at the both of them, there's sine waves now that we're determining it. Right? It moved forward, around, down, and backward. As you look at both particles, the one is actually the opposite of the other. Now, it's just like a tennis ball being cut in half.
You could now see which percentage was correct. And it turned out the winner was quantum physics. Particles were just apparently making up their spin results on the spot, which is spooky, because not only does that call in...
They were just making up their particle stuff on the spot. More likely, they were just being affected by the stuff as it was happening. No quantum entanglement at all. Dude, you just disproved quantum entanglement. Can people please shut up about quantum entanglement now? It's over. It died with your video. You might say a lot of things right and wrong, but when you say the results are, if that's the actual results, then that's the conclusion. There is no such thing as quantum entanglement. The particles aren't talking to each other. When you do stuff to one, it doesn't do anything to the other. They just do their own thing.
Question our perceptions of reality itself, but that also means that the moment one particle decided on its spin result, its quantum entangled partner instantly knew that that decision had happened. You could test both.
In other words, no, it's not that it decided, it's that when you divided the particle into two particles, which is what actually is happening, when you actually look at them, they look like opposite particles. But if you were to then line them up again, you'd notice the one is, they're still having the same rotation. But when you look at the one, this looks like the opposite. Which way is it? This is clockwise. This is counterclockwise. Clockwise. Counterclockwise. Did I change how I was turning my hand? No. Clockwise. Counterclockwise. I'm not changing how I'm rotating my hand. It's a continuous motion. Clockwise. Counterclockwise. It's funny how that works, isn't it? There's no quantum entanglement there. It's the same thing. Clockwise. Counterclockwise. Same object, same direction. Weird, huh? Yeah. an object waving will seem to be moving in the opposite direction if looked at in the opposite orientation. Wow! Fancy how that works! Quantum entanglement busted! Fuck off! There is no connection between the particles. There's no long-term signals that can be made in this way. It's enough. Also, other things you have to know about space and time is that time doesn't dilate and space doesn't curve. But we'll talk about those in other videos. You literally clockwise, right? Follow my finger. I haven't changed what I'm doing. Counterclockwise, right? How does it do that? Counterclockwise. Clockwise. Wow. Eh? Okay. If you understand quantum physics now, it's because you actually saw something that resonates with your brain so directly that quantum entangled particles have this same property. And when you're looking at them this way, they do that. When you're looking at them this way, they do this. I'm sorry. That's just how it is. It means you can't use quantum entanglement for communication. Anyone talking about quantum entanglement and quantum computers are forgetting how quantum computers actually work. It has nothing to do with quantum entanglement and other such things. But whatever, if you don't ever watch my video, if you don't ever learn about real science, I feel sorry for you. Do it slower. Clockwise. Right? Still the same direction. As you look at it this side, counterclockwise. It's the same thing. It's the same thing. This way, that way. Same thing. Same thing. How is it? Counterclockwise, same rotation of the object, clockwise. How does that work? It's like a gear meshing with itself, only the difference is I'm not doing anything different with my hand. Clockwise, counterclockwise, same motion with my hand. Same thing happens with the particles. One is twisting in that way. When you look at it from one orientation, the other one's doing the opposite thing. Because it's in the other opposite orientation. Or it could be that it is manufactured so that instead of moving this way, it's actually turning the opposite direction. But either way, what you're seeing is a particle interacting with its electromagnetic fields that are around it, nothing else. And if the particle is spin up, then it means it's doing this clockwise thing. If it's spin down, it's doing this clockwise thing. Counterclockwise thing. Does that mean the time is moving backwards? Because counterclockwise is when it goes from 12 to 11. 10, 9, 8, 7, 6. And clockwise is when it goes 1, 2, 3, 4. No. It's just an orientation in space. It's a mirror of the same thing. It's the same thing, oriented, spinning in a different direction. My hand is not doing anything different. That you can do this yourself. You can be like, it's spinning, and it's spinning this way, and it's spinning, and it's spinning that way, and it's doing it, and it's like, this is definitely counterclockwise, and this is definitely clockwise, and you're not doing anything different with your hand. You're just changing how the hand's directed. The reason why I want to repeat and keep saying it, and say it over and over again, and say it a different way, and say it again, and make it clear, is because I feel like people don't understand how quantum stuff works. If you understand that it's a particle doing this thing in this way, and if that's what's actually happening, then there is hidden variables, there is no quantum entanglement. They're just doing random stuff based on the energies that surround them and stuff. And I've said it already, and I'm saying it again because I'm mentally unstable. But anyhow, I'm going to go do a driver's test in a few hours, and I need to eat something substantial instead of just a clementine. Toodles!